My name is David. I am a principal engineer at Spice.ai. I spend a lot of time working on the distributed query functionality, and here today with a demo to show you all the little bits and pieces and the kind of thing that you could do with it in Spice. So AWS has a large public data set of the Bitcoin blockchain. And they have this available on S3. Anybody can connect to it without any credentials. It's a large Hive partition bucket of blocks and transactions. And what we're going to do today is use this Spice pod to run some fun queries and see how all the pieces work for distributed query. So I have here both of the data types that we're going to look at today, blocks and transactions represented in the Spice pod. I have my S3RL with Hive partitioning enabled. We have acceleration turned off because this initial preview of distributed query only supports these large data lake formats. After I have all of this set up, I'm going to go over to my terminal and start a scheduler. To start a scheduler, we pass cluster mode scheduler. And when you're testing locally, you can pass allow insecure connections. You should not deploy in production without enabling TLS and an API key. We have the API key piece demonstrated here. So we start a scheduler, and then we are going to start two executors locally. To start an executor, you specify cluster mode executor and then pass your cluster API key. You can use our secrets integration and you'll be able to deploy this securely with the Helm chart. This is just to demonstrate functionality locally. And once you start a scheduler and at least one executor, you could start running distributed queries. So let's start off by asking Spice to show what tables we have. So I see transaction blocks here. They're both loaded. Let's take a look at transactions very quickly to get a feel for the schema. We have the block hash number, the input value of the transaction, output value of the transaction, and a bunch of metadata in the outputs list. Same thing for blocks. A block has many transactions. What we're going to do is take a look at some fun, basic stats that are kind of difficult to do within the scope of a single process. But here with our cluster, we have two executors, each with, I think this machine has like 10 or 12 cores. Okay, in a production scenario, these will be deployed in separate hosts. Let's try to start with something easy where we're going to look at the total transactions in the last 24 hours. I ran an explain query so we could see what the plan is to actually get us the answer. So that came back. We see over here that logical plan just shows the sort of aggregate, basically what is the query. The physical plan tells us more about how. And there's now a distributed plan which takes this base physical plan and splits it out and distributes it across different stages. This is a really simple aggregate, so this can happen in these two easy stages. So now let's run the actual query and see how many transactions we got in the last 24 hours. And this is up to date. They update it every day. And this is actually the last 7 days. So in the last 24 hours, or at least the 9th of December, there's about 448K transactions. I have an aggregator brought up, which offers the same kind of metrics. They say 445K, but it's still very cool. They do this incrementally, but we were able to just run that query in about 8 seconds. And then there's all kinds of fun queries that you could run. I have another one here to find the largest blocks by transaction count. This one is interesting because it has to crunch quite a bit of data for the last 30 days. You could see in my console distributed jobs to both of the executors, and we already have an answer. It looks like the biggest block last 30 days is 927082 with about 7,000 transactions. So distributed query is a cool way to get started with exploring these larger data sets, but I want to bring it full circle and also loop in some AI pieces. So I have OpenAI set up with a prompt that instructs the model to answer questions about this AWS public data set. And what's cool is that if you make the model aware that it can explain queries, you can actually get it to tell you the rationale and sort of how it arrived at the query and why it made the choices that it made. So I uncommented that block in my Spice pod. I'm going to save and now run the scheduler again. We should see that we have the model ready to go for inferencing. I'm going to run my executors again. The cool thing about distributed query is this demo doesn't use distributed inference capability, but you can see as these are starting up over here, the model also deploys on the executors, so it's ready to go. So let's run a Spice chat session. And now let's ask it the same thing as the first query. What are the total number of transactions in the last 24 hours? You'll see immediately after I asked the model this question, it spawned a query. Query is running on the cluster, and soon enough, I should have back the same figure we had earlier. I also instructed the model to tell me a bit about the query, and you could also follow up with a question. What was the plan for that query? And it should try to subsequently run and explain. Here we go. We have an answer. It tells us about the logical and physical plan and what each of the steps does.